At this point in time, we have always assumed that our rolled steel beams are compact shapes. Now, what compact is, or compactness is a shape that will not buckle locally. Now, local buckling is a different type of buckling. It's based on the shape and how it's rolled and how thick the flanges are and how long the flanges are and how thick the web is and how long the web is. It's based on whether that becomes unstable and actually buckles in a local fashion. Now again, this is not the same as lateral torsional buckling. Lateral torsional buckling is a function of unbraced length of the compression flange. Local buckling is a function of how long versus how thick the flanges are, and also how long and thick the web is. If the flanges are very long and slender, or the web is very long and slender, they could actually buckle because the compression force is too high. Now, that being said, most rolled steel beams are not going to experience this local buckling. Most rolled steel beams are in fact going to be compact when we use steel strengths having yield capacities of 50 ksi or smaller. However, we can check this, and the AISC gives us two fairly simple compactness checks, one for the flanges and the other one for the web. And basically what we do is we calculate a parameter called lambda. For the flanges it's called lambda PF. But that parameter for the flanges is just the flange width divided by 2 times the flange thickness, or B sub F divided by 2T sub F. Now that value is actually found in the property tables. So again, you can go to your W-shaped tables and scan on over to the right side of the page, and you'll actually see this parameter listed there for every shape. Now what you do is you compare that parameter to, as it's shown on the screen, a value of 0.38 square root of E over Fy. Again, when Fy is 50 ksi or smaller, the vast majority of our beams will be compact for their flanges. For the web, you do basically the same thing. You calculate a parameter. This time it's H over TW, the height of the web divided by the thickness of the web. Again, that's going to be a value that's actually listed in the property tables, so you can just look that up and then make sure it's less than or equal to 3.76 square root of E over Fy. If that's the case, then the web is compact. Again, you can do these compactness checks, but most of the time when you're using an Fy 50 ksi steel, you're going to find that your beams are compact.